3 to a 4. Our computers can deal with numbers which are this big. They can do all kinds of great computations with them. And if we're doing geometry, steps in complexity in some actual specific situation, you're actually making computations, then you shouldn't be surprised to have bigger and bigger numerators and denominators occurring. Typically what happens. When you make addition of fractions or multiplication of fractions, then the denominators and the numerators generally get bigger. So every time you make a computation, then you're increasing sizes. And so it doesn't take that long before you can realistically end up with numerators and denominators that are of this order. We want to be able to deal with that. We don't want to just throw up our hands and say, I'm sorry, that's no longer supported by our theoretical constructs. So we want to do bigger arithmetic, and so we need to free num from net. We do not want to identify these two things. We do not want num to just be a replacement or a short form for net. That's too limiting. So notice how this understanding really does depend on our investigations of bigger numbers. And our investigation of complexity, we're thinking about complexity. We have the sense that there's limits out there in terms of how big you can write down expressions. And correspondingly, how big are the numbers that you have some realistic hope of writing down in some fashion or another. And so we're trying to address that. We're not pretending that we're living in some unicorn kind of universe where there's an infinite amount of room and we can just do infinitely many things just by waving the hands around. We're not doing that. We want to really pin things down solidly. So what we want to do is we want to free num from that. We want to have our Hindu-Arabic number system allow us bigger arithmetic than we can do just with that. That is great, but we want to do something more. So let's look at a separate line of inquiry. Let's think about Hindu-Arabic numbers as a separate system from that, but which correlates with it. So that's our aim, to try to see some direction in which we could create a theory of natural numbers based on Hindu-Arabic representation. Okay, so this is a lot more work. This is a lot fancier than dealing with the natural numbers. It's several orders of magnitude more complicated than that. In fact, the claim has not yet been done. In 2016, there's no place where you can find a proper theory of Hindu-Arabic numbers. In particular, piano-type axioms, some of you will have heard of an axiomatic approach to numbers. So the piano axioms don't really help us either because piano is resting on the idea of building up natural numbers by successes. And if you want to start with 1 and then you add 1 and then you add 1 and then you add 1 and 1 and you want to kind of build up an arithmetic, you're really essentially in the realm of primitive natural numbers. Okay, so piano is just an axiomatic approach to what we're calling natural numbers. In fact, it doesn't really aid us considerably, but we'll talk about piano at some other point. But in any case, piano is not going to help us going beyond the primitive natural numbers. We need to do something else. We need to go beyond this need to have our numbers connected with an actual M set or a sequence of things that we can write down starting from 1. Okay, so here's a rough outline of how to proceed. So here's a program that somebody could think very carefully about and work towards creating a theory of Hindu-Arabic numbers. Isn't it remarkable that in 2016 such a program is possible? That there's this road that could be gone down by somebody who's careful and serious enough and really wants to do some work. To establish arithmetic. That's what we're talking about. It's not some tangential thing built on top of the extremities of the theory, built on the extremities of some other theory. Okay? This is core mathematics we are discussing here, isn't it? Okay, so how can we start? We can start by defining Hindu-Arabic numbers as expressions like this. Okay, that's not so hard to do. So a Hindu-Arabic number is an expression like this. What does that mean? Well, it's a list, or if you like a string, of digits. The digits are all taken from this set. The usual ones, 0 to 9. And the strings have the property that we're going to be arbitrary, except for the rule that they can't begin with 0. They can't begin with 0, except for the single number 0 itself. That's the only number that can start with the digit 0. By start, I mean the leftmost, the digit 0. And all this must be non-empty. We're not allowing any empty lists. Alright, so that is a reasonable definition of what a Hindu-Arabic number is. So we can agree that you have a Hindu-Arabic number precisely when you can write down such a string. You can write down a string like this one, you have a Hindu-Arabic number. So we don't need to suppose that there's some set somewhere that this is counting. Okay, the Hindu-Arabic number is just this string that we write down. That is a very sensible and concrete and reasonable way of defining these things into distance. That'd be like step 1. Okay, so now that we have the objects, the numbers themselves, we are obliged to define the operations. So, say addition and multiplication, the two ones that we usually start with. How are we going to define these? So note that now it's no longer possible for us to go back to the natural numbers. We can't say take your Hindu-Arabic number and find an M set or collection or set that has that many objects in it, and take your other Hindu-Arabic number and find another M set that has that many, and then dump them together and then count how many we have. Okay. That works only if we're in the realm of possibilities for exhibiting these M sets. and we've already sort of flagged that we are going beyond that. Okay? So we cannot rely on just converting our Hindu-Arabic numbers to natural numbers and working there. But nevertheless, we can still connect with what we're doing with natural numbers. So we could create addition and multiplication tables. Okay, and so here's an addition table for just the digits themselves, and here's a multiplication table for the digits themselves. Well, the tables are not complete, but I'm sure you can all complete them. Okay, so one can sort of write down these tables and say, this is how we're going to define the addition of just our Hindu-Arabic numbers, which are given by single digits. If we want to know what is 2 plus 6, we look at the table and say, it's 8. If we want to know what is 2 times 7, we look at the table and say, it's 14. Okay, so of course this table doesn't tell us how to add more generally, but it's a start. Okay, so we give these tables and we define the operations on the single digits this way. And of course we all know that these things do come from our understanding of natural numbers, primitive natural numbers, and how addition and multiplication work for them. But in fact we don't really need to say so. Okay, we can just say, here are 2 tables, and we're going to define addition and multiplication by these tables. That's how we tell our computer how to add digits. We have to explain to the computer where we got these things from. All right, so now for the second part of that second step, we need to extend our understanding or definition of addition and multiplication to general Hindu-Arabic numbers. Okay, because we've had lots of experience with this in primary school, we know, at least in principle, how this should proceed, or roughly anyway. But we know how to use those addition and multiplication tables to add and multiply more general numbers. We want to add 2, 3, 7, and 49. We know that we start on the right and we add 7 and 9 using the table. We get 16, we write the 6, we put the 1 up there. And then we add 3 and 4. We get 7, we add the 1, we get 8. And then we bring the 2 down. So we want to multiply 2, 3, 7 by 4, 9. Well, we multiply 9 times 7 is 63. We write the 3, we put the 6 up there. Then 9 times 3 is 27. We add the 6, that's 33. We put the 3 down, there's a 3 coming up there, etc. All right, so it's a question then of taking the familiar knowledge about how to actually add Hindu-Arabic numbers and telling our computer how to do that. That's essentially what the definition is. So extending our definition from single digits operations to general string operations. So this is a fair amount of work, but it's not impossible. You can certainly program a computer to do this. And in fact, if you look at computers that have code that works on Hindu-Arabic numbers, well, they have something like this. That's what they do. And then we have another challenge, which is to prove the laws of arithmetic. This is more challenging than you might think, because you are not allowed to use the prior knowledge of arithmetic with natural numbers, with primitive natural numbers, okay, except for small numbers. So we can use the fact that for small numbers we know that 3 plus 7 plus 8 is the same as 3 plus 7 plus 8. So we can use those things, but we don't know that associativity or say distributive law or even commutativity is necessarily going to be operating on these huge Hindu-Arabic numbers. Of course, we have some intuition that they will. Okay? But it's not a valid argument to say, well, we just convert these big Hindu-Arabic numbers to M sets, and then we do the primitive natural number operations there, and we know that things are commutative or associative or distributive there, and then we go back up. So the argument only holds up to the limits of our natural or primitive natural number system. And we're proposing to go much beyond that. So we need separate, independent proofs of the laws of arithmetic. You can see that there's something to be done here, and it's actually a considerable amount of work, and it's not all immediately obvious what the most efficient and elegant way of doing this is. It's going to be a great mathematics project, I think. A student can easily spend a year or two thinking about how to do this really in a nice, elegant way. It's very instructive. Okay, and so if we went down this road, which I'm broadly outlining here, we could put that together and then get a new system, which we call NUM, Hindu-Arabic numbers, which extends the arithmetic of natural numbers.